Imagine you're walking down a busy modern street in Seattle. You're grabbing a coffee, uh,
Yeah.
checking your GPS to find a new restaurant.
Right, maybe just looking up at a clear blue sky.
Yeah, exactly. But what if I told you that just a few feet beneath your shoes is a completely abandoned, burned out 19th century city?
I mean, most people would think you're making that up.
Totally.
Hmm.
And what if I told you that the GPS in your hand only works because engineers are actively altering the flow of time, like mathematically compensating for the speed of the Earth just so you don't get lost on your commute?
It sounds like pure science fiction, but it is the strict applied reality that we live in every single day.
It really is. And that is exactly what we're getting into for today's deep dive. We're pulling from this incredibly detailed, highly verified collection of documentation known as text.
Yeah, the text collection is really remarkable.
It is. And our mission here is to explore how your everyday human perception of reality, like your basic assumptions about time, history, and the physical world, how all of that is constantly being shattered by verifiable scientific truths.
Because we navigate our lives relying so heavily on our intuition. We trust the ground is original. We trust time is constant.
Right, that physical objects are permanent.
Mm.
But we're going to see how those comforts dissolve pretty quickly. We're starting with a catastrophic woodworking accident, and somehow we're going to end up on a distant planet that literally rains molten glass.
Which is wild, but what's great about the text documentation is it strips away human bias. It forces us to confront how our universe actually operates.
Instead of how we wish it operated.
Exactly. And as you hinted at with Seattle, sometimes that confrontation starts literally from the ground up.
Yeah, let's talk about the ground we walk on. Because the history of our cities isn't always safely locked away in a museum. Sometimes we build our daily routines directly over forgotten catastrophes. Set the scene for us in 1889 Seattle.
Well, picture a bustling, rapidly expanding American frontier city. It's built entirely on low-lying mudflats, and almost every single structure is made of timber.
So, a literal tinderbox.
Completely. And on June 6, 1889, in a basement woodworking shop, an assistant makes this one careless mistake. He leaves a pot of glue boiling on a stove.
Oh, no.
Yeah, it boils over, catches fire, and he actually tries to put it out with water.
Which, if anyone knows anything about grease or glue fires, is the absolute worst thing you can do. It just spreads the burning material everywhere.
Precisely. That one spill ignited a fire that raged completely out of control. And it didn't help that the city's water pipes they were also made of hollowed out logs.
Wait, the water pipes burned too?
Yeah, they ended up burning right along with the buildings. By the time the ashes settled, 25 entire city blocks were completely annihilated. It was the core of Seattle's business district.
Okay, let's unpack this.
Yeah.
Because in the aftermath of something like that, you'd expect a massive cleanup operation, right? Like, sweep the mess away, rebuild with brick this time.
You would think so.
But the city officials looked at this burned-out, muddy landscape and decided to do something entirely unhinged. It's like sweeping a mess under a rug, except the mess is an entire 19th century city.
Well, they had always suffered from terrible drainage issues because they were at sea level. High tides would literally back up the plumbing into the streets.
Ah, gross.
Yeah, so city engineers saw the destruction as a blank slate. They mandated that the new streets be raised, not by a few inches, but by 1 to 2 entire stories.
I have to stop you there. How do you just raise a city street by 2 stories while people are trying to live and work there?
It was a chaotic feat of civil engineering. First, business owners were told to rebuild their new stone and brick buildings at the original low mud level.
Okay.
Meanwhile, the city built these massive concrete retaining walls running parallel to the new buildings, outlining where the new, higher streets would eventually go.
So the sidewalks are down at the bottom and the streets are up high.
Right. For a while, the streets were giant raised walls next to the buildings. People had to use towering wooden ladders just to cross the street from one side to the other.
That sounds like an absolute nightmare.
It was incredibly dangerous. But eventually, they pumped millions of tons of dirt and mud from the nearby hills into the space between the retaining walls. That created the new elevated street level. And finally, they paved over the gap between the new street and the second story of the buildings.
So the second floor of these businesses suddenly became the ground floor.
Exactly.
That's just wild. It's like building a pristine hardwood floor directly over a shattered tile floor instead of just cleaning it up. They entombed an entire functioning ground level.
That's the perfect way to visualize it. I mean, it
Yeah.
really shows human resilience literally burying the past to build a better future. And the original storefronts didn't vanish.
They're still there.
They still exist today, completely underground. You can actually take historical walking tours beneath the modern sidewalks of Seattle and wander through those dark, abandoned corridors.
Wow. Modern residents are quite literally walking on an artificial reality, built right over the charred remnants of their own past. It fundamentally changes how you perceive the permanence of human civilization.
It really does.
We think we're standing on bedrock, but we're often just standing on the scaffolding of the people who came before us. But if human beings are out here burying our past to build a better future, what happens when nature decides to hide things from us?
That is such a good pivot because the transition from human geography to biological history reveals this incredible blind spot in our scientific timelines.
Yeah, just as the streets of Seattle hide a forgotten city, the depths of the ocean hide biological realities that actively defy what we thought we knew about extinction.
We have this really rigid concept of extinction, don't we?
We do. We dig up a fossil, date the rock, draw a line in the sand, and declare a species gone forever. And paleontologists did exactly this with a deep-sea fish called the coelacanth. Based on the fossil record, the entire scientific community agreed universally that this creature died out 66 million years ago. Like, checking out right alongside the dinosaurs.
The scientific consensus was absolute. The textbooks were completely finalized, and they remained unchallenged until a very specific day in 1938 in South Africa.
Yeah, a museum curator named Marjorie Courtney Latimer is just doing her job, examining the daily catch of a local fisherman.
Just looking for anything interesting for the museum displays.
Exactly. She's picking through regular fish, and then she spots something completely impossible. It's this enormous, strange fish with heavily armored scales and deep blue fins that looked almost like small legs.
Yeah, what's fascinating here is how the deep ocean acts as an undisturbed time capsule. It preserves biological reality while the surface world transforms entirely.
What did the scientists say when she actually showed it to them?
It caused sheer cognitive dissonance. I mean, when the leading ichthyologist of the time received her sketch, he later said a bomb seemed to burst in his brain. Upon official examination, they confirmed it wasn't a hoax. It was a living, breathing coelacanth. It had been swimming around in the deep ocean trenches for millions of years, completely ignoring the fact that human science had pronounced it dead.
I mean, to put 66 million years into perspective, it's basically the biological equivalent of taking a casual walk in your local woods this afternoon and just stumbling across a living T-Rex munching on a deer.
That is a terrifying but accurate analogy.
It's so arrogant of us. How is it physically possible for a complex animal to simply not evolve or die out over that unimaginable stretch of time?
It comes down to the extreme stability of its environment. The surface of the Earth is chaotic. Over the last 66 million years, the surface experienced catastrophic ice ages, asteroid impacts, continental drift.
Violent climate shifts. Yeah.
Exactly. That chaos forces surface animals to evolve or die. But down in the deep ocean trenches, thousands of feet below the surface, the environment is practically static.
So it just didn't need to change.
Right. The temperature doesn't change. The pressure doesn't change. The coelacanth found a perfectly stable, hidden pocket of reality and just stayed the same.
It really exposes the arrogance of human timelines. We base our understanding of biological permanence on the shallow, rapidly changing world we can easily see. It makes you wonder if our grand timelines of extinction are sometimes just a map of where humans haven't bothered to look yet.
It absolutely proves that our perception is severely limited by our environment. Organic life, when left alone in a stable environment, can maintain an unbroken chain for eons.
Okay, so nature can preserve a biological fish for 66 million years without changing a single scale.
Yeah.
But what about the objects that human beings specifically engineer to last forever? Because if the literal building blocks of our reality are so fluid, is there anything we can actually trust?
Well, for a very long time, we tried to anchor our trust in physical objects. The global scientific community desperately needed a standardized baseline for mass. We needed a singular, unchangeable anchor for reality.
Right. From 1889 until 2019, if you wanted to know the exact definition of 1 kilogram, you didn't look up a math equation. You looked at a physical cylinder made of platinum and iridium.
Le Grand Quai.
Exactly. It was locked inside a highly secure, climate-controlled vault in France under, like, 3 nested bell jars. Every scale, Every global trade measurement, every scientific calculation involving mass on Earth ultimately traced back to that one specific piece of metal.
It was the literal standard of the world.
Yeah.
But the physical universe is relentless.
Right.
Over the decades, scientists would periodically bring together the official copies of Lagrange K from around the world to compare them against the master cylinder. And they discovered a crisis that threatened the foundation of modern science.
Wait for it.
Lagrange K was losing mass.
Wait, hold on. It was locked in a highly secure vault in France. Nobody is taking a cheese grater to it. How does a solid piece of platinum and iridium just lose mass if it's heavily guarded and protected from the elements?
Because on a microscopic level, nothing is truly isolated. Every time the cylinder was handled for cleaning or measuring, microscopic abrasions occurred. Furthermore, physical metals interact with the air. They absorb microscopic contaminants or they off-gas trace amounts of material. Over a century, these invisible interactions meant the master kilogram was diverging from its copies by about 50 micrograms.
50 micrograms. That sounds like nothing. I mean, that's the weight of an eyelash. Why did scientists consider this a crisis?
Because of what that cylinder represented.
So what does this all mean? Like, practically?
Well, imagine you are building a towering skyscraper, but the ruler you are using to measure all your steel beams is invisibly shrinking every single day.
Oh, wow. The building will eventually collapse.
Exactly. In the realm of advanced physics, international trade, pharmaceuticals, any fluctuation in the baseline definition of mass throws the entire global system into slow, invisible chaos.
So the literal definition of the kilogram is dissolving. And to stop the drift, in 2019, the international scientific community essentially voted to abandon the physical world.
Yes, they retired the metal cylinder.
But what did they replace it with?
This raises an important question about physical stability. They replaced it with pure mathematics. Because human-made physical objects are inherently flawed. Today, the kilogram is defined by a fixed mathematical constant of the universe. Planck's constant measured using an incredibly complex instrument called a Kibble balance.
Wait, back up. I need an ELI 5 on this. What is a Kibble balance and how does abstract math replace a solid piece of metal?
Think about how an electromagnet works. If you run an electrical current through a coil of wire, it creates a magnetic field.
Sure.
A Kibble balance uses this principle to balance a mass. Instead of weighing a kilogram against another physical object, it weighs the kilogram against the exact amount of electrical power needed to hold that mass up.
Oh, interesting.
Because electrical current and voltage can be tied directly to fundamental quantum constants like Planck's constant, we can define mass using the unchanging laws of quantum mechanics, rather than a piece of metal that sheds atoms.
We literally had to rescue the concept of mass using quantum math because a physical piece of metal couldn't be trusted. That blows my mind.
It's a huge paradigm shift.
Okay, so if the fundamental building blocks of physical mass are unstable, what else is broken? What about time?
This is perhaps the most profound disruption in the text collection. We intuitively experience time as a steady, universal ticking clock. Like a minute feels like a minute whether you are sitting in your living room or flying in an airplane.
Like, time is just time.
But Albert Einstein proved that this intuition is a complete illusion. Time does not move at the same speed for everyone.
Here's where it gets really interesting. You're talking about the theory of relativity. Why would doing something physical, like moving fast, actively change something abstract like time?
It helps to stop thinking of space and time as two separate things, and instead think of them as a single fabric, space-time.
Okay.
Einstein realized that the speed of light is the universe's ultimate unchangeable speed limit. It is the one true constant. So if you start moving incredibly fast through space, something has to give to ensure you don't break that universal speed limit.
And what gives is time.
Exactly. The faster you move through space, the slower you move through time. It is a biological and physical reality called time dilation.
So it's a cosmic trade-off. If I spend more energy moving through space, I get less movement through time. Like a streaming video that buffers at different speeds depending on how fast your internet connection is, but here the connection is your physical speed.
That's a great way to think about it. And if we connect this to the bigger picture, this incredibly abstract, mind-bending physics isn't just theoretical. It is an applied engineering requirement for modern civilization to function.
You're talking about the GPS satellites?
Yeah. Yes. The satellites powering global navigation are caught in a massive tug-of-war with relativity, subject to two competing variables. First, they're orbiting high above the Earth, where gravity is slightly weaker than on the surface, and Einstein proved that weaker gravity actually causes time to speed up.
Okay, so weaker gravity makes their clocks tick faster.
Yes. But the second variable is speed. These satellites are hurtling around the globe at roughly 8,700 miles per hour. As we just discussed, that extreme speed causes their clocks to slow down relative to observers on Earth.
So they're speeding up because of gravity, but slowing down because of velocity. What is the net result? Do they cancel out?
Not quite. The gravity effect is stronger. When you combine the two forces, the atomic clocks on those satellites tick slightly faster than identical clocks sitting on the surface of the Earth.
Wow.
They drift away from Earth time by about 38 microseconds every single day.
Microseconds. Again, human intuition screams that this doesn't matter. But the text documentation outlines the terrifying reality if we just ignored that microscopic drift. GPS relies on absolute pinpoint timing, right?
Absolutely. The satellite sends a time-stamped radio signal to your phone, and your phone calculates exactly how long that signal took to arrive to determine your distance.
And because radio waves travel at the speed of light, an error of just 1 microsecond in the clock translates to a distance error of about 1,000 feet on the ground.
Right. So if engineers didn't actively program the software to mathematically correct for Einstein's time dilation,
Within a single day, your GPS would be off by miles.
within a week, global navigation, aviation logistics, and the entire supply chain would completely fail.
We have to outsmart our own intuitive reality just to keep modern civilization functioning. That is wild.
It proves that highly abstract physics is actually a strict engineering requirement.
So we've covered how local earthly physics are deeply deceptive. The ground is fake, biological timelines are an illusion, physical mass degrades, and time literally bends. If our assumptions are this flawed at home, what happens when we look out into the broader universe?
Well, we find that our human biases fail us on a cosmic scale. A perfect example in the documentation is the exoplanet HD 189733b. It's located 64 light-years away from Earth.
Yeah, astronomers pointed the Hubble Space Telescope at this distant world, and they were able to determine its true color. It is a stunning, deep, beautiful cobalt blue.
It looks very familiar.
Right? As a human being, when you look at a beautiful blue sphere floating in space, your brain instantly triggers a comforting association. We project our earthly reality onto it. We think of calm, life-giving oceans. But the data from Hubble confirmed an environment that borders on a horror movie.
Because reality simply does not care about our visual assumptions. The planet's deep blue color has absolutely nothing to do with water. The atmosphere of HD 189733b is saturated with silicate particles.
But why does a sky full of silicates look blue to us?
It's a process similar to how our own sky looks blue, called light scattering. But instead of the light scattering off nitrogen and oxygen like on Earth, the starlight hitting this exoplanet scatters off microscopic particles of magnesium silicate in the atmosphere.
Okay.
These particles scatter blue light far more efficiently than red light, creating that magnificent cobalt hue.
But magnesium silicate is essentially the building block of glass. And this planet orbits incredibly close to its host star. The data shows temperatures exceeding 1,600 degrees Fahrenheit.
That is 870 degrees Celsius. That is hot enough to melt those atmospheric silicates into liquid form.
And it gets worse. The planet is locked in a state where one side constantly faces the star, creating massive temperature differences that whip up supersonic winds.
We are talking wind speeds of 5,400 miles per hour.
Over 8,600 kilometers per hour.
So you combine liquid silicates, unimaginable heat, and supersonic winds.
You get a planet that literally rains molten glass sideways at thousands of miles per hour. It is the ultimate cosmic trap. You are looking at this serene, familiar blue marble floating in the dark, and in reality, it is a sideways, supersonic glass blender. It is genuinely terrifying.
It really illustrates how profoundly our Earth-centric bias limits us. We assume that because the physics of light scattering creates a peaceful blue sky and blue oceans on Earth, the universe must use that exact same visual language everywhere.
Right.
HD 189733b proves that the exact same visual input can be generated by an environment so violent it defies human imagination.
This entire journey through the text collection has been an incredible exercise in dismantling our assumptions.
Mm.
I mean, we started by exploring how a mundane 1889 glue fire forced a city to physically bury its own architecture, turning modern sidewalks into roofs for a forgotten world.
Yeah.
We uncovered a deep ocean time capsule holding a 66-million-year-old survivor. We watched the absolute baseline of human measurement, the physical kilogram, literally evaporate until we replaced it with pure quantum math.
We really covered a lot of ground.
We learned that the steady ticking of time is just a localized illusion that requires constant daily correction to keep our technology functioning. And finally, we saw how a comforting blue planet is actually a storm of sideways glass.
The most valuable takeaway for you listening to this deep dive is recognizing the necessity of intellectual humility. Human intuition is a fantastic survival tool for navigating a savanna, but it is utterly inadequate for understanding the mechanics of reality.
Absolute.
True learning requires us to accept that the universe operates on layers of complexity that we are only just beginning to decipher. Embracing that strangeness is what drives discovery.
That is perfectly said. And, looking back at our discussion on time dilation, it leaves me with one final, deeply provocative thought.
Oh, what's that?
We know that gravity and speed alter the passage of time for our satellites right now, but what happens centuries from now when humanity eventually becomes a multiplanetary species?
Oh, wow.
Think about it. If we build permanent colonies on planets with vastly different gravitational pulls, say a massive super-Earth, or a tiny low-gravity moon, how will that permanent time dilation affect human biology and the aging process across generations?
That is a fascinating question.
Will the concept of a human lifetime mean completely different things depending on which planet you call home? Will a family reunion across the stars require complex relativity math just to figure out who the oldest sibling is? It's something to seriously mull over the next time you look at the clock on your wall.
It is a staggering implication. When the fundamental rules of reality are this fluid, the future of human experience is wide open.
Well, that wraps up our deep dive today. Thank you so much for joining us on this exploration of the strange, beautiful, and highly documented reality we inhabit. Keep questioning the solid ground beneath your feet, look a little closer at the world around you, and as always, keep digging deeper. We will catch you next time.